And I'm so happy today to have with us Mr. Avinash Kasinathan, Executive Vice President, Strategy and Technology from WayCool Foods and Products. Thank you so much for accepting, to give us this presentation and to share with us your vision for this key topic, I think, in sustainability and in smart agriculture.
Thanks a lot. Thanks a lot to everyone from Must. Happy to join you all here as well. I'd like to briefly provide a context into why I chose this topic and how this is core to what we do at WayCool and take all of you through some of the interesting technology initiatives and how technology is core to how we look at addressing the supply chain. I think a lot of discussions would have happened from illustrious and exciting team members in terms of how do you improve yield, how do you improve productivity to ensure that you're getting high quality produce and high quantity of produce as well. What I felt which we should also deal with, therefore, is there's a lot of interesting work which goes on in terms of how do you get the high quality produce. But what is important is after all the efforts which has gone into producing the good food, you should not be wasting food, right? And this, as rightly said, is a issue not just in India but across different parts of the world as well. But I'll just still give a context of the situation in India as the slides just come up. So India has a very large but inefficient food supply chain, right? There are a lot of people even within India and maybe perhaps outside India as well who might believe that India might actually have a shortage of food. But this is not true at all. India is the second largest producer of food in the world. And we have more than 760 million tons of food being produced and consumed throughout. So what is the actual issue from an Indian food supply chain, right? The supply chain, while being very large, is extremely inefficient. What happens, as you can see on the screen here, there are anywhere between 5 to 11 steps between the farmer and to the end customer where the food moves through the supply chain. And why is this happening? See, unlike some of the countries like United States or maybe some of the European nations as well, most farmers hold very small areas of land. Majority own less than 2 acres of land. So on a particular day, they'll be able to harvest, say, 2 tons of produce. But any vehicle which has to go from a long distance from the farmers to the end consumers is typically at least a 25-ton vehicle, right? So which means you need to aggregate multiple farmer supplies and then carry it through the transportation. Similarly, on the consumption side, right? Unlike again in some of the countries like US, where you have a lot of large supermarkets where most of the food purchase is happening. In India, 80 to 90% of the food is purchased through the local mom and pop stores, or what we call as the Kirana stores. Again, one Kirana store is not going to be keeping full quantity of a 25-tonner vehicle, which again means you need to disaggregate the produce and move in smaller vehicles, which does a milk run and drops off material in multiple small Kirana stores. So this is why you have an aggregation at the farm side and a disaggregation at the customer side. Along with understanding supply, demand, and so on, you will have anywhere between 5 to 11 steps in this supply chain. What happens, but the important thing to note is most of the members in the supply chain are extremely unorganized and fragmented players. So what therefore means is there is limited information flow across the supply chain. So while the demand is actually pretty inelastic, I mean, we consume pretty much very similar kind of food throughout the year. But the supply becomes very uneven and prices become very volatile because the farmer is not able to exactly judge what the end customer needs, right? Because there are so many steps in between. And what we typically call in operations or in supply chain parlance as a bullwhip effect kicks in, where the farmer is producing based on what he thinks is the demand which he has heard from somebody just next to him in the supply chain. The person next to him in the supply chain is hearing from the person who is after him, and so on. So never is there a real-time information flow in terms of the actual demand basis which the farmer is able to cultivate his production. So you have both extremes happening in the same year, right? There are months where the produce is so much higher than the end consumption. There are months when the produce is extremely low. This in turn means that the prices go anywhere from 1 cent a kg for something like tomato to more than $1 per kg. So there's a 100x volatility which happens within a year's time. And not only that, the most important thing is, as a result of this, there is more than 35% food wastage in the supply chain itself. Just to give a context, 35% of food wastage in India equals to the entire food which is consumed by a country as large as Brazil. So this is what motivated us to look at what is the situation with the full food supply chain. Why is it the way it is? And how do we look at bringing in technology to reimagine how a food supply chain should be? So that's where we built a tech-led supply chain. So we've cut down the steps, what was 5 steps for fruits and vegetables to 2 steps, and what was 11 steps for non-fruits and vegetables, the staples, where there's an extra layer of processing required, to 3 steps, right? So instead of 5 to 11, it is now 2 to 3 steps. You have the harvesting and the crop management by the farmers. You have collection centers, again, completely managed by players like WayCool. There's which collects the material. There's a warehouse which does the supply demand matching. And then there's the last mile distribution to the end customers. So not only do we, in this process, reduce the number of steps, so the bullwhip effect, which I spoke about, is significantly reduced, but also the fact that there is one player like us who's connecting the farmers to the end customers means that there is a lot more control of the entire supply chain. And what is critical for this to work is to have one seamlessly integrated technology platform for all the members, whether it's external or internal stakeholders in the system. So we have one platform which talks to the farmers, which talks to the processors in between, to the warehouses, to the distribution logistics partners and the delivery partners, as well as the retail stores and then the end customers. What this ensures is that the demand which is required by the end customers, the information instantly flows back to the farmers. It flows to the collection centers, warehouses. So they all plan the processing, they all plan the movement of material, vehicles are arranged, all in line with what the actual end demand is. Right? And this ensures that this 35% of wastage which you have is significantly reduced to almost 5% because of this real-time information flow which is happening across the entire supply chain. Right? So it is not about a technology from the perspective of something which is scientifically really new or which matters in this sort of a space. What matters is having everybody, all the stakeholders on one platform and ensuring that there is a material flow, money flow or information flow is pretty much transparent and visible to everybody involved. So because of this, what we've been able to do is the whole planning exercise becomes significantly efficient. Based on the customer's demand, our warehouses forecasting planning tool, actually lays out 2 levels of forecast. One is a long-term forecast, which is 3 to 4 months away, which directly goes into a supply plan for the farmers. And farmers plan and cultivate crops based on what the demand would be at the time of harvest, which is 3 to 4 months away, as opposed to what the demand is at this point of time, which could be very misleading in terms of a supply-demand mismatch. So this planning becomes accurate and more instantaneous. As a result, farmers grow based on this. And of course, all the other information, all the other knowledge and advisory which we provide to the farmers also additionally helps them get a 50 to 30% earnings boost over what they would have had earlier. But the real advantage is coming in because the collection centers and the warehouses are tuned to what is required and what is coming in, and therefore are able to match every supply to the demand which is required. There is full transparency. The value addition happens at the relevant sources, again linked to the demand. And we have fully automated warehouse systems, which ensures that there is limited physical touch of the material and therefore the wastage is reduced by a 25%. This also helps us ensure that the customers get what we call as a fill rate, 98% fill rate, which is if a customer, which is like a retail store, wants 100 items, we're able to ensure at least 98 items are received by them, which in a B2B parlance is extremely great. Typical averages in India would be at an 85% or so. And not only this, based on the understanding of the customers, the feedback again flows back to the farmers, flows back to the different processing centers and so on, and you're able to plan material accordingly as well. Just a little bit more in terms of how do we manage to do that in terms of the technology itself. We have a multi-dimensional tech stack, which is on the one hand integrated across all the stakeholders, as I said, the farmers, processors, warehouses, the distribution management systems, and the end customers. You're getting all of them into an integrated, scalable digital platform. And there are different pieces for the different players. For the farmer, you have multilingual supplies tracking solution. For the warehouses, you have the shop floor automation, which is where the moment the crates arrive, it is automatically directed to the relevant end customer. And then this whole distribution management system ensures that there is a network optimization and the logistics is managed successfully, while the end customer orders based on the demand, based on the supply available as well. Not only do we have this integrated platform, the analytics, so not on top of the digital platform, we have the analytics engine as well, which helps in the crop cultivation planning, the quality grading, order supply matching, route optimization, and then recommending the right set of products to the customers. On top of this, we build in the other peripheral services for the farmers in terms of the right set of seeds to obtain the right inputs and so on, as well as the financing across the stakeholders in this system. So we provide a full stack of services to each of these members in the platform, which ensures that this whole stakeholder system operates as a robust operating system in a very seamless manner, right? And our technology platform itself is built in such a way that it is modular but connected. So the pieces for each of the stakeholders are talking to each other, and they talk to other external solutions as well. So the farmer systems can easily plug in any smart precision farming equipment. So whether it's to do with weather stations, it's to do with soil testing, it's to do with other yield improvement methods, it's to do with drones, which can help view in terms of the pests and all of that. All of that gets easily integrated into the platform directly. The IoT sensor systems, which is required as part of the conveyor systems, all of that gets integrated into the rapid platform for the warehouses. Similarly, you have multiple systems integrating on the customer side for the financial lending and all those support as well. So the core here is actually, once again, repeating what I mentioned earlier, to ensure that you have a single source of truth through an integrated platform, where the entire set of practices to be followed by each of the members and the core planning is embedded within it. So this is just an example in terms of how we go into the depth, right? So if you look at the farmers, we start all the way from the planning in terms of based on the demand forecast which we have. How do I convert that into the crop plan? Then into the sowing and growing period. What is the right set of seeds to provide? What is the right inputs to provide? What is the right set of irrigation practices to provide? The third is in terms of the price discovery, right? So once the material is ready for harvest, you have a 3-4 days window to harvest a particular material. The prices fluctuate quite a bit. So the right access to the prices has to be provided to the farmers so that they know which day to harvest versus whether to harvest today or whether to keep a little bit more and harvest slightly later so that they get better returns. And once they are ready to harvest, to be able to immediately provide transportation to the farmer to obtain the material from them instantly, because once harvested, the life of the produce starts deteriorating. So you should have the transportation immediately ready. Then after the quality checks of the products to ensure that there are no rots which would otherwise spread across the produce, right? And then finally the payments to the farmers. So this is an example in terms of how the entire process being digitized makes and the information flow being readily available to the farmers makes their planning, sowing, and cash management very, very effective. I spoke about how we have the conveyor systems in the shop floor, where the moment the material reaches the shop floor, it is already the crates are already tagged, and based on the tag identification in the shop floor, it is automatically mapped to the end customer based on the quality of the product, the perishability, and how it would reach the end customer as such. And the third element is around the whole last mile logistics planning. How do I ensure that based on the demands which I have from the customers and the material which I have to provide to the different shops and the plan and the locations of the different shops and the time by which they need the material, how do I ensure the route planning is optimized? So that we are able to not spend too much in terms of foot miles and the logistics costs, but at the same time able to ensure that the material reaches the customers within the right time. So that optimization again helps in terms of low cost, but ensuring that material is moved fast to the end customer without any wastages or damages happening. So all of these, along with the physical automation I spoke about in terms of the robots for handling the material, the intelligent cross-docking system between the intermediate logistics and the last mile logistics, grading, optical grading machines for quality checking, automatic packing machines and tracking, crate tracking. All of these automations along with the software layer which is moving across the supply chain ensures that today we move more than 90% of the material from harvest to the end consumer within 24 hours. So all our customers eat products wherever they are from in South India in less than 24 hours since they are harvested. And because it is so robust and that tight in terms of the length, both the length of the supply chain and the amount of time the material stays in any leg of the supply chain, we are able to do significantly reduce the wastage by up to 25%, which means you have 25% less material which you will actually have to produce, and thereby you will have a lot more sustainable growing patterns which is possible. This is what I wanted to talk about today, and I'm happy to answer any questions as well. Thanks a lot.
Thank you so much, Avinash. It's for the presentation. I think it's clear. I have several questions for you. First, the question is: this platform more in terms of architecture, more social media architecture, or you are deploying API, to plug the other, all the members, all the supply chain members?
Yeah, so we've built our own base platform itself through an API architecture as well. So one is we have our own in-house applications, and we have APIs again from the front-end applications talking back to our databases, which is also open to other players who can plug into this as well. So it is API-based architecture.
It's API scalable architecture. Then the other question: what about the governance of such system? Means it will be your company who will manage the system, and if yes, what is your business model?
Yeah, so we are actually, I think, just to clarify, so technology is the one of the most important arms of the company, but we actually manage the entire supply chain itself. So we actually buy material, move it through the supply chain, working with the various stakeholders and to the end customers. So naturally, our stakes are very high, right? So we are handling the material ourselves, which is why we actually invest a lot into the controls and governance which goes into the system. And it's a very important point you raise. I think a lot of players, consumer tech players who have perhaps entered the agri-tech space, believe a lot of times if you just have a way to accumulate the demand from the end customers and then work with the farmers, you'll be able to run this supply chain effectively. But that's not true, right? I mean, all these, as we discussed, there's a lot of controls which is critical for the planning to work as seamlessly as it is planned, right? So which is why a lot of the effort which goes into the development of the solutions is around the controls and the governance, which are automate itself, right? So, for example, the logistics, no one decides which vehicle has to move which material. It is automated based on what are the orders available, what are the vehicles available. The crops which has to be grown by the farmers is again automated based on the demand forecast which comes in. and directly provided. It's not like some human being who is saying that this is the crop you should grow. Similarly, the automated systems in the warehouses, the supply crate is automatically matched to the end demand customer. No, again, it's a decision not made by individual; it's made by the systems itself. So you have controls and governance as a very key part of every step of this technology which has been built.
Okay. The last question, how AI is in your roadmap? Because we have seen the previous 2 days a lot of systems, and we see also many, expectation from introducing AI and machine learning technology to get prediction and decisions. And you are in this prediction and decision. How you see machine learning in your roadmap?
Yeah, no, it's a it's critical part as well. So as I was sharing one of the slides, 3 things have to work together for us to be able to manage this from a technology perspective. One is just the integrated digital platform across all the stakeholders. Second is the physical automation wherever possible, especially in the warehouses and the collection centers. The third leg of this is the embedded analytics in each of these parts, which uses AI ML to make decisions which are not only optimizing at a local level for that particular stakeholder, but optimizing at a global level across the entire supply chain itself. So as I said, planning is very core to us, right? So starting from the demand forecasting towards converting that into a crop cultivation calendar, towards even the ability to predict which supplies would come when, and therefore map it to the end demand, as well as to also shape the demand. For example, at the Kirana stores, we do a lot of work with mom and pop stores using AI ML algorithms to recommend the right set of products which they should stock in their stores based on what the consumer habits are. So across all of these segments, AI ML plays a very important role. And more data you get, the more accurate you get in terms of how successfully you're able to use these tools as well. So we've had now about 5-6 years of data ever since we started out, and you're already starting to get richness in terms of predicting the supplies, predicting the prices, predicting the demands. Also, quite interestingly, predicting the consumer behavior in terms of what material works well. I mean, and especially the consumer behavior, where it gets interesting is it can get very granular. We can go to literally a street by street level, 100-meter street by street level, to say in this street, this variant of rice or this variant of wheat is preferred. Whereas in the others, and in the other street, 50% of the people would want this, another 30% of the people would want something else, and so on. This is not based on just surveys and market research. This is just based on the past ordering behaviors and the patterns which have developed and how that is shifting. So the way that so we actively use AI/ML to map the demographic patterns and the consumer behaviors to shape the demand at the different stores which have to be there, and based on that do the planning for the supplies as well as processing and so on.
Thank you so much, Avinash. I think is clear, and really hope you the best, because you started by it looks more matter than what we have seen in some cases, and you have a lot of data. I think this will help the system and will help you to get results rapidly. Thank you so much. Hope you all the success.